Transformations. Remembering that by transformation, we just mean doing the opposite operation on both sides of the equal sign. So first example, 5n minus 9 equals 71. Now, we've done some equations like this before, and the way that I like to describe it is first leave the variable term alone and undo the other operations first. The book describes it in a slightly different way, but either way, this is probably how I'll be explaining it, so if a different way makes more sense to you, you can look in your book and see how it describes it. But again, in this, I've got two operations here on the left side. I've got multiplication and I've got subtraction. So we're not necessarily following PEMDAS because we're not solving this yet. We don't know what n equals yet. But we're going to leave the variable term alone and undo the other operations first, which means for this example, I'm going to be starting with the minus 9. I'm going to undo that, just like before, by doing the opposite. I want you to write that step down where you do the opposite. The harder these get, the easier it is to make a mistake if you skip these little steps of writing down what you're doing. Minus 9 and plus 9 make 0, so we can cancel them out. Now I'm left with 5, 9 equals 80. Remember, we're not done yet. We're going to have multiple steps here to solve. Now, just like yesterday, since it's multiplication, I do the opposite. I divide by 5 on both sides. 5 divided by 5 makes 1, and 1n is what I need to have. 80 divided by 5 is 16. So we're using the same strategies of undoing by doing the opposite on both sides. It's just that we're going to have a lot more to do. So I'm going to show you a few different examples. I think I've got 4 or 5 examples here. Remember that when you get stuck on a problem from the homework, to look at your notes. The homework problems should match up with these different styles of examples that I'm showing you. So next example, 1/2 x plus 3 equals 9. According to what I said up here with the rules to follow, what should I do first here to try to solve this, Jaden? Good, I'm going to leave the 1/2 x alone. I'm going to start with the other thing. Since the other thing is plus 3, I do minus 3 on both sides. That leaves 1/2 x on the left equals 6 on the right. Now we've got a problem that looks a lot like yesterday's. 1/2 is being multiplied by x. The opposite of multiplying by a half is to divide by 1/2. 1/2 divided by 1/2 equals 1. 6 divided by a half becomes 6 times 2 over 1. And we get 12 over 1, or just 12. So again, just combining all these. Yes, Izzy? I'm sorry, say it again? No, if it's a fraction, I need you to use a fraction. Okay, next example. W minus 5 over 9 equals 2. Now again, the same rule applies even though it looks a little different. We're going to leave the term with the variable alone to start. Now that, it's actually 2 different terms, but what that means is I'm going to leave the numerator part alone. Look for where the variable is and leave that part alone, start on the other stuff. Now the other stuff is over 9. What operation is that? Brian? Yeah, this is divided by 9. So I'm going to undo that first. Instead of divided by 9, the opposite would be times 9 on both sides. 9 divided by 9 leaves 1, which leaves an exact copy of what we had, or just cancel them out. 2 times 9, whenever there's just plain numbers on one side, solve it, simplify it, put them together. do the operation, in this case multiplication of 2 times 9. Now, last step, all I have to do to get the w by itself is undo minus 5 by doing the opposite, and w equals 23. So again, wherever the variable is, you leave that part alone, try to undo the other stuff that you see. Okay, 2 more. Stop me if you need me to review anything that I've showed so far. Next one, 32 equals 7a plus 9a. This one's different in that we're not going to undo anything to start. Like I said a second ago, if you have numbers, like, let me show this again. Here, 2 times 9. If you can simplify those, simplify them. We did 2 times 9 and got 18. Is there anything I can simplify on this one? Jim? Yeah, okay, so these are like terms. We can only add them because they both have the same variable with the same exponent. If I have 7 a's and 9 more a's, all I have to do is combine those like terms to get 16a. There's no other operations that don't have a variable that I could undo. So I'm going to combine the like terms. Now all I have to do, that's 16 times a, is divide both sides by 16. Now the way this equation was set up, we get 2 equals a. If I said the answer was a equals 2, hopefully you know that those are the same, right? I don't care which side the letter ends up on. They're the same thing. So you can just leave it like this. Okay, last example. One more and then we're done. Let's combine a bunch of stuff. Why don't we? 4 times y plus 8 minus 7 equals 15. Woohoo. Good times. There's a couple different ways we could solve this. I'll show you 2 ways. First would be to do the distributive property with this 4. I can't add the y plus 8, so if I distribute that 4 by multiplying it by both parts, 4 times y, 4y. 4 times 8, 32. I keep the minus 7, the end, the equals 15. Now, is there something I could simplify here? Leanna?
32 minus 7.
Yeah, I can do this math. I'm not moving them. I'm not doing the opposite. They're on the same side of the equal sign. So I just do the math on 32 minus 7, and I get 25. Now we're kind of like looking at a problem that looks like the first example I did a little bit. So we did that distributive. We simplified by combining the like terms. What would I do next? Daniel?
Minus 25 on
Okay, we're going to leave the variable alone. We can't divide by 4 yet. We're going to leave that alone. We're going to undo the other thing first. The other thing is plus 25, so I do minus 25 first. 15 minus 25, negative 10. Final step now is to divide by 4. Negative 10/4. Now, you can leave this as an improper fraction if you like, if you simplify it. Both of these divide by 2. So if you leave it as this, that's fine. If you want to tell me it's negative 2.5, that's also correct. If you want to tell me it's negative 2.5, that's also correct. So that's one way to do it. Let me show you the shorter way. The second way for that same problem is shorter, however, you've got to be careful about the order that you do it in. Any questions first before I take this down on how I did that one? Okay, now again, if I'm moving too fast and you ever want to borrow these notes, all you have to do is come ask me. Let me show you a quicker way to do that problem. Because there is more than one possibility here. I said at the beginning, leave the stuff with the variable alone. That means I'm going to leave this whole first part alone that has the distributive property. And I'm going to start with this minus 7. Brian, do you have a question, or were you going to suggest that? That would be correct. The thing we have to be careful of here is that we can't even do this, this is 4 times, I can't divide that yet. I have to leave this whole part alone and undo minus 7 by doing plus 7. Now I've got 4 times y plus 8 equals 22. Now at this point, you could divide by 4. This is 4 being multiplied, we could divide it. However, as you guys can probably see, when I do 22 divided by 4, I'm going to start to get fractions. So now, the easier way now is to do the distributive property. This really is not a huge difference in time from the previous way, it's just a different way. I think it feels shorter, I don't know why. We're kind of doing the same steps. Now we would do minus 32. We're down to 4y equals negative 10, so I'm not going to finish all the way. Well, I will, it'll be quick, but it's the same ending as before, which is good. It should be the same answer. So just to show you that on a problem like this, there might be more than one way you could start it. We end up with the same answer, doing the thing with the part with the variable very last. Okay? So that's it. Just go carefully, go slowly, look at your examples.